It happens so often now that I think we barely even register the sheer scale of the operation anymore.
Oh, absolutely.
Like you're sitting on your couch, right? You open an app, you find that, I don't know, very specific configuration of a blender or maybe a pair of running shoes you've been looking for, and you just click buy.
Yeah, and then instantly the screen updates.
Exactly. It updates and makes this bold, definitive promise,
Yeah.
delivery by Tuesday.
It is a remarkably confident statement when you think about it. Just a definitive fact delivered in milliseconds, Tuesday.
Right, and you just accept it and move on with your day. But if you stop and actually analyze that interaction, how do they know?
It's wild.
Like, how does a massive global company juggling factories on one side of the planet, shipping lanes across the ocean, warehouses right in your region, how do they know with absolute mathematical certainty that they can fulfill that promise to you by Tuesday?
I mean, it looks seamless on the front end, obviously, but the back end reality is this continuous, massive web of calculations that literally never sleeps.
And that is exactly what we're getting into today. Welcome to today's deep dive. We know you are curious about the hidden mechanics of global business, those invisible frameworks that keep everything humming along.
Yeah, the stuff you don't normally see.
Right. So today we are pulling back the curtain on supply chain planning. Our source material for this analysis is a highly technical but honestly incredibly revealing excerpt from the APCS Certified in Logistics, Transportation, and Distribution.
The CLTD learning system.
Right, the CLTD learning system, specifically Module 2.
Which is great because the APCS material is essentially the gold standard for understanding how supply and demand actually align in the real world. It breaks down the mathematical governance of corporate production.
Okay, let's unpack this because we are going to be diving into concepts like ERP, MPS, PAB, ATP, and MRP.
It is quite the alphabet soup.
It really is.
Yeah.
But by the end of this deep dive, those systems will transform from just abstract corporate jargon into a really fascinating logical sequence. We're going to see how global business actually functions, step by calculated step.
Yeah, and to understand that sequence, you really first have to understand the stage all this math operates on.
Right.
We need to look at the enterprise resource planning system, the ERP.
Because before a company can calculate a single delivery date for your blender, they need a central nervous system.
Exactly.
A framework where all the data lives. I mean, we literally can't discuss scheduling or promising deliveries without discussing the overarching architecture holding the data.
Right. And the source text defines an ERP at its core as a framework for organizing, defining, and standardizing all of a company's business processes.
So it gets everyone on the same page.
Exactly. But the fundamental feature that makes the rest of our discussion possible is its shared central database.
So instead of the finance team running their own, disconnected financial models and the warehouse operating off some localized inventory software.
And sales using their own proprietary CRM.
Right, exactly. Instead of all that mess, everyone is tapping into the exact same data set. It's kind of like a giant, flawlessly synchronized master Google Doc for a massive corporation.
That's a really good way to put it. The text emphasizes that this architecture minimizes data redundancy. Because, consider a massive corporation attempting to function without an ERP.
It would be chaos.
Total chaos.
Yeah.
The sales team might look at their localized system, see some inventory, and promise a major client a massive order.
But they have no idea what's happening on the ground.
Right. They have no visibility into the manufacturing team's system, which might show that a critical molding machine is currently down for maintenance.
Oh, wow. Or like the purchasing system showing a delay in securing raw materials.
Exactly.
It would be analogous to trying to run a global air traffic control system where every single control tower uses a totally different radar frequency.
Yeah, you're just asking for a crash.
Right. So I see the ERP as that unified radar. If the warehouse updates a stock number in Singapore, the sales team in New York sees that update instantaneously.
It physically prevents the sales team from making a promise the warehouse simply cannot keep.
Which is pretty crucial.
It is. That unified radar is the perfect way to visualize it. But we should clarify a technical distinction the text makes here.
Okay, what's that?
Well, while the ERP is the overarching framework, the database holding the truth, it is not always doing the heavy analytical lifting of the scheduling itself.
Oh, interesting. So it's holding the data, but not doing the math.
Right. For that, it relies on what the text categorizes as supply chain execution systems.
Ah, okay. This is where we get into APS, right? The Advanced Planning and Scheduling System.
Yes. APS is the mathematical engine. It takes all that unified static ERP data and uses complex algorithms to perform optimization
Okay.
and finite capacity scheduling in real time.
Let's dive into that real quick, that finite capacity scheduling, because that seems like a massive upgrade from legacy systems.
Oh, huge.
Because older systems often assumed infinite capacity, right? Meaning the software would schedule production, assuming you had an unlimited number of machines and workers.
Which is obviously impossible. Infinite capacity planning is a recipe for factory floor disasters.
Yeah, I would imagine.
So APS uses finite capacity scheduling, meaning it juggles a massive range of real-world constraints simultaneously.
Okay, so it looks at reality.
Yeah, it looks at machine limits, labor availability, material constraints.
To put that in context for you listening, if the ERP says we have an order for, say, 10,000 blenders, the APS is the system that says, wait a minute, we only have 3 molding machines.
Right.
And they can only run 18 hours a day before overheating. We only have enough raw plastic for 5,000 units right now. And oh yeah, the third shift is short-staffed.
Exactly. And then it evaluates multiple scenarios to figure out the optimal schedule that honors all those constraints without breaking the delivery promise.
Wow.
It resolves the conflict between what we want to do and what we physically can do.
So the ERP holds the single source of truth, and the ATS crunches the physical reality of how to execute on that truth. Which brings us to the next massive challenge. A factory gets these long-term aggregate forecasts from the corporate level, right? Like, we expect to sell 100,000 blenders this year.
Yeah, a huge number.
I find the scale of that transition really compelling, like how a business takes these huge aggregate plans for entire product families and distills them into a granular daily schedule for the assembly line.
Yeah, that transition mechanism is called master scheduling, or MS.
Scheduling, okay.
Master scheduling takes those aggregate, high-level plans and disaggregates them.
Yeah.
It breaks them down into specific units of individual products.
So going from the big picture to the details.
Right. And the output of this entire process is the Master Production Schedule, the MPS.
Okay, the text defines the MPS as the anticipated build schedule for specific configurations, quantities, and dates.
Yes.
It is the company moving from a fuzzy forecast to a hard commitment, stating they will produce exactly 500 units of the red 12-speed blender in week 3.
What's fascinating here is how the source material addresses the friction between that commitment and the volatile reality of the market.
Oh, because consumer demand is notoriously unpredictable.
Exactly. A specific product trend can go viral overnight on social media, suddenly shifting demand completely from the red blender to the blue one.
And if a company were simply reacting to real-time data without any governance, without any rules, they would be frantically changing their manufacturing schedule every single hour.
You just can't do.
Right. That would cause massive whiplash on the factory floor, drive the workers crazy.
It would destroy their operational efficiency and their profit margins. I mean, you cannot simply halt an assembly line halfway through a production run, swap out all the tooling, and begin building a different configuration.
It might take forever.
It incurs massive changeover costs and delays. So to prevent this, the APSC's text introduces the concept of time fences.
Okay, time fences. So the master scheduling grid is divided into zones, basically.
Yeah.
Separated by these fences, establishing rules for when and how the schedule can be altered. And the text outlines 3 distinct zones, right? Starting with the frozen zone.
Right. So in the frozen zone, capacity and materials are completely committed to specific orders.
They are locked in.
Locked in tight. This is the immediate near-term schedule. Only senior management is authorized to make changes here.
Oh, wow.
And they generally avoid it because altering the frozen zone is prohibitively expensive.
But let's introduce some real-world corporate friction here. Say a VP of sales has a massive client who suddenly demands a rush order of blue blenders tomorrow.
Okay, classic scenario.
The factory manager points to the frozen zone and says, nope, the red blenders are already being assembled. Doesn't the math break down if human politics get involved and the CEO just forces the change anyway?
Well, yeah, if leadership routinely overrides the frozen zone, the integrity of the entire supply chain model just collapses.
This is just a free-for-all at that point.
Exactly. Yeah. The mathematical optimization we discussed earlier becomes totally useless because you are introducing infinite variability. The time fences act as corporate governance. They enforce discipline.
Okay, so assuming that discipline holds, just outside the frozen zone is the demand time fence, which opens up into the slushy zone.
I love that term, the slushy zone. It provides a negotiated flexibility. The schedule isn't locked down entirely, but it's constrained by the materials you've already ordered.
So you have some wiggle room.
Yeah, the master scheduler is empowered to make decisions and trade-offs here.
For instance, swapping a 220-volt European motor for a 110-volt North American motor on the exact same blender chassis.
Exactly, assuming both motors are currently in stock. You can tweak the mix, but you can't overhaul the entire production block.
You are operating within the boundaries of what is already in motion.
Right. And then, once you cross the planning time fence, you enter the liquid zone.
Which is wide open.
Wide open.
In the liquid zone, you can completely overhaul the schedule as long as it fits within the higher level business limits, right? Because you haven't committed the raw materials or scheduled the specific labor yet.
Exactly. It provides a necessary buffer. You have the safety of the frozen zone for near-term execution, the negotiated flexibility of the slushy zone for the midterm, and the strategic agility of the liquid zone for the long term.
So knowing that we have these time fences governing the schedule, we have to look at how the master scheduler knows when to actually slot in a new batch of production. Like if they were looking at the slushy or liquid zone, they rely on specific calculations on the master schedule grid to trigger a new build order. And the first is PEBI, or projected available balance.
Right. Projected available balance is an inventory balance projected into future periods.
Okay.
The foundational formula is your beginning inventory, plus any scheduled supply minus your expected demand.
Simple enough. But the APCS text highlights a really elegant shift in the math depending on which side of the demand time fence you are operating on.
Yeah, it's very clever.
The formula itself dynamically alters, doesn't it?
It does. It adapts to the reliability of the data. So prior to the demand time fence, when you are in the frozen zone,
Right.
the PAB is calculated using actual book customer orders as your demand figure.
Oh, because in the frozen zone, you only care about tangible reality. You are executing on what has actually been purchased. Nothing else matters.
Exactly. But once you move past the demand time fence into the slushy and liquid zones, the PA formula modifies its demand input.
Okay, how so?
It now uses the greater order of either the statistical forecast or the actual customer orders.
Oh, I see the mathematical logic there, because if you are looking 2 months into the future, you might only have, say, 50 actual customer orders currently booked.
Right.
But your historical forecast indicates you typically sell 500 units in that specific month. If you only plan your production based on the 50 tangible orders you have right now, you are mathematically guaranteeing a massive shortfall.
You'd run out of stock almost instantly. You have to hedge your bets using statistical probability. You realistically expect more orders to materialize, so you plan for the higher number.
That makes total sense. So the ERP system tracks this PIB number period by period.
Yes.
And when the projected available balance dips below a certain threshold, specifically the required safety stock level, right, that serves as the mathematical trigger.
Exactly. It signals the master scheduler that a stockout is imminent in a future period,
Oh, okay.
prompting them to schedule a master production schedule receipt, basically a new batch of production to replenish the balance.
It essentially creates a self-regulating loop based on a blend of cold facts and intelligent predictions.
It's a very robust system.
Now, here's where it gets really interesting, because pay tells the factory when to build. But there is another vital calculation on the grid called ATP, available to promise.
Ah, ATP.
This is the exact mechanism that empowers that consumer website we talked about to confidently promise the Tuesday delivery.
Right. ATP represents the uncommitted portion of your inventory and planned production.
Okay.
It is the inventory that is truly free to be allocated to new incoming customer orders.
So a good way to conceptualize ATP is to think about dependent obligations on a checking account.
Oh, I like this analogy.
Right. Like you might log into your banking app and see a total balance of $3,000. That is your physical on-hand inventory.
Sounds pretty good.
Yeah. And if you only look at that top line number, you might think, hey, I have plenty of capital to book a luxury weekend vacation.
Which totally ignores the reality of your pending liability.
Exactly. You know, you have a $1,500 mortgage payment pending tomorrow and a $500 auto loan draft the day after.
Yeah, that money's basically already gone.
Right. So your actual available to promise balance, the uncommitted portion you can safely utilize without defaulting on your existing obligations, is really only $1,000.
That is exactly how ATP functions. It prevents a company from double booking its assets.
That would be a nightmare.
It really would. The system calculates the total incoming supply and on-hand inventory. It subtracts the orders already promised to other customers, and the remaining delta is the ATP.
Okay, so when you click buy online.
The system pings the ATP database.
Huh.
If the value is greater than 0, it confirms your delivery date and instantaneously decrements the ATP so no concurrent user can claim that exact same unit.
It's just brilliant. And, the text mentions a highly specific database treatment for calculating ATP when dealing with perishable goods. They refer to it as the non-cumulative or discrete method.
This is a critical distinction in the database architecture. If a company is managing products with rigid expiration dates like pharmaceuticals, chemicals, or fresh food items, they cannot mathematically carry unused ATP inventory forward into future periods.
Because it goes bad.
Exactly.
With a non-perishable good, like our blender, if you have an ATP of 100 units in week 1 and no one buys them, the database just rolls that ATP over, right? So you have those 100 units available in week 2.
Right, but the non-cumulative method prevents that rollover.
So it treats them separately.
Yeah, the database has to decouple period 1's inventory from period 2 mathematically. It isolates the availability strictly to the period before the expiration date hits.
Wow. Otherwise, the system would be mathematically promising spoiled or expired goods to future customers.
Which is a great way to lose all your customers.
And get sued. Okay, so we have the ERP acting as our central data framework. We have our master schedule utilizing Paybe to determine that we need to build 500 units in week 4, buffered by our time fences.
Right.
And we use ATP to confidently allocate those units to consumers on the website. But an assembly line is completely paralyzed if it lacks the raw materials.
Yeah, you can't build a blender out of thin air.
Exactly. How does the factory ensure the motors, the blades, and the plastic housings are physically present on the floor exactly when the schedule demands them?
That transitions us to material requirements planning, MRP.
The ultimate ingredients list.
Basically, yeah. MRP is the engine that synthesizes the master production schedule, the real-time inventory data, and the bill of material.
The BOM.
Right, the BOM, to calculate the exact requirements for raw materials and subcomponents. But to really grasp how MRP functions, we must highlight a major conceptual difference outlined in the text.
Okay, lay it on me.
The distinction between independent demand and dependent demand.
This is a vital separation of concepts, I feel like.
It really is.
Mm-hmm.
Let's analyze a complex product like a refrigerator. The demand for the finished good, the fully assembled refrigerator, is independent demand.
Because it's based on the customer.
Exactly. It is driven by external market forces, by consumers deciding to purchase an appliance. You must use statistical models to forecast independent demand.
Okay. But the demand for the refrigerator's compressor or like the internal crisper drawers?
That is dependent demand.
Ah.
It is entirely dictated by how many finished refrigerators you have committed to building in your master schedule. You do not forecast dependent demand. You calculate it with absolute certainty.
Right. If your master schedule dictates a build of 500 refrigerators, you know mathematically that you require exactly 500 compressors.
Yes. Attempting to forecast dependent demand using market trends would introduce massive error margins. It would lead to either severe shortages or excessive inventory bloat.
Exactly. If we connect this to the bigger picture, MRP is the automated system managing all that dependent demand.
Okay.
It takes the MPS output, the 500 refrigerators for week 4, and it executes what supply chain professionals call exploding the bill of material.
Exploding the BAME. I love that phrasing.
It's very dramatic. Exploding the BAME means the system analyzes the parent-child relationships in the product data. It breaks down the finished parent good into every single child component, subassembly, and raw material required to construct it.
And modern products have multi-level bills of material, right? Like a refrigerator needs a door, the door needs a handle, a rubber gasket, and sheet metal.
Right. It's layers upon layers. And the MRP multiplies the quantities required at every single level by the 500 finished units scheduled.
So it generates this comprehensive, multi-tiered requirements list. It does. But the true power of MRP is its temporal aspect. It manages timing through lead time offsetting.
Meaning it works backward through time from the final deadline.
Exactly. MRP checks the exploded requirements against what is currently on hand in inventory. For the net requirements, it offsets the required dates by the lead time of the external suppliers or internal subassembly processes.
Okay, let's trace that timeline backward for a second. If we need those 500 refrigerator doors on the main assembly line in week 6, and it takes the internal stamping department 1 week to form the doors, the MRP schedules the stamping order for week 5.
Perfect. And if the stamping department requires raw sheet metal and the external steel supplier has a 3-week lead time, the MRP offsets again.
It calculates that a purchase order for the sheet metal must be executed and sent to the supplier in week 2.
Right. It synchronizes the entire supply chain timeline and ensures components arrive just in time.
Preventing capital from being tied up in excessive raw materials just sitting on the warehouse floor collecting dust.
Exactly. While simultaneously ensuring the multi-million-dollar assembly line never halts due to a missing component.
It transforms a chaotic, multivariable guessing game into this predictable, highly calculated flow of materials.
It is honestly a beautiful system when it's all running smoothly.
So what does this all mean? We started by examining a simple interaction, clicking buy on an app and receiving a Tuesday delivery promise.
Right.
And to back up that promise, we've traced the logic through the unified database architecture of the ERP. We examined the finite capacity optimization of the APS and watched the master schedule convert forecasts into commitments, rigidly governed by time fences.
We analyzed the dynamic math of projected available balances and the stringent allocation rules of available to promise.
And finally, we saw MRP explode the multi-level bill of materials, offsetting supplier lead times to orchestrate the arrival of every single component.
Yeah.
The next time you order something online, you are not just looking at a generic shipping estimate. You are interfacing with the ATP output of an MRP process, driven by an MPS within a global ERP framework.
It is an intricate, continuous optimization problem being solved globally in real time.
It really is a marvel of industrial engineering. But before we sign off, I want to leave you with a final thought to ponder based on the system.
Okay.
Throughout this analysis, we've seen how all of these mathematical frameworks, MRP offsetting, KB depletion, ATP allocation, they all rely heavily on stability.
They do.
They require predictable, stable lead times to keep inventory perfectly lean and costs minimal. The math offsets the sheet metal order by 3 weeks because the data assumes the freight network always takes exactly 3 weeks.
Which raises a very important question about systemic fragility.
Precisely. What happens to this highly optimized, quote-unquote, perfect math when a global shock overnight doubles every lead time across the world?
Yeah, we've seen that happen.
We've witnessed ports shutting down, canal blockages, sudden geopolitical shifts. How brittle does a mathematically perfect, lean supply chain become when the real, unpredictable world throws a massive wrench into the constraints?
It's a scary thought for anyone in logistics.
It really is. Because when reality no longer matches the database, the time fences can only offer so much protection. Just something to think about the next time your Tuesday delivery suddenly shifts to Thursday. Thanks for joining us on this deep dive. We'll catch you next time.